Welcome to our collection of videos showing different aspects of quantity surveying. My name is Kylie Rowland. These videos are based on New Zealand and Australian legislation, but are similar and all the same worldwide. Please check your local authorities for guidance and confirmation. Understanding measurements in quantity surveying. Accurate measurements are the foundation of successful project delivery. It is the heart of every construction project, and it is critical to be precise on both materials used and amounts required. Precise measurements directly influence cost efficiency, good project outcomes, and ultimately client satisfaction. I will be discussing compliance with New Zealand legislation, the importance of accurate measurements, types of measurement units, be giving a practical example, identifying challenges, and providing tips. It is essential to follow the New Zealand Building Code. New Zealand standards, acts, and manufacturers' installation instructions are devised to ensure compliance with legal and quality benchmarks. The main legislation devised for measurement is the Australian and New Zealand Standard Method of Measurement 2022. This document was first introduced in 2018 and it replaced the NZS 4202. The purpose of the ANZS MM 2022 is to provide a uniform basis for the measurement of building works. It is broken down into different trades and it is a rational approach to measurement and documentation. It provides the most up-to-date industry practice and good trade practice, ensures uniformity and consistency, aligns design team, contractors, subcontractors, quantity surveyors, project managers, suppliers, and it also aligns Australia with New Zealand. Measuring methods in construction refer to the standardised techniques and procedures used to quantify and assess the work needed to complete a construction project. Precise measurements directly influence the quality and the cost efficiency of the project. Accurate measurements is essential to ensure the correct quantity of material is ordered and accounted for. Accurate measurements is also essential to establish the scope of works, secures structured resource allocation, avoids errors and delays, provides well-organised project planning, assists with risk management, demonstrates efficiency and transparency, and ultimately leading to client satisfaction. It is a baseline for efficient planning and scheduling, sequencing, ordering, avoiding delays, and limiting interruptions. In order to follow government legislation, adherence to the ANZS MM 2022 requires specific measurement units per material. This includes linear meters, for example stud framing, square meters for building wrap, cubic meters for concrete, number could be for doors and hardware, and kg/ton for reinforcing steel. I'd like to use timber wall framing as a practical example. Timber wall framing is a fundamental aspect of many buildings, particularly in residential and light commercial construction. Timber is accessible, cost-effective, and easy to use. Accurate measurements for timber framing is essential to ensure the frame fits properly and that the overall structure is built to the required specification, making it structurally sound. As you can see from the diagrams, wall framing consists of plates, studs, trimmers, nogs or drangs, lintels or headers, and the sill trimmer. The New Zealand standard for measuring a timber frame wall is the NZS 3604 timber frame buildings. The NZS 3604 sets the minimum standard for the design and construction of timber frame buildings. Importantly, This standard is followed by building consent authorities and building industry regulators, so adherence is vital. The NZ 3604 is also practical guidance to meet New Zealand building code requirements without the need for specific engineering design. You ensure that it is confirmed by the architect that this is included in the plans and not a specific build. Using the NZS 3604 2011 timber frame buildings, you can find, for example, timber and lintel dimensions and stud centres. This is established using the table 8.2 and determined by any of the factors below. So whether it's a load-bearing wall or a non-load-bearing wall, one story or multi-story, what kind of subfloor there is, light or heavy roof, wind zone and geographical location. Horizontal timber would include the top plates and the bottom plates, which will run along the length of the wall, the nogs or dwangs, which also run along the length of the wall. Lintel dimensions should be established on the drawings or stated as following NZS 3604 2011, and trimming sills run the length of the window. For vertical timber, it may be a little bit more complicated. First, you have to determine the length and the height of the wall. The timber thickness and width needs to be established, and you also need to determine the spacing between studs. This is known as centres. Mostly it's used is 400 centres and 600 centres. So you divide the length of the wall by the stud centres to determine the number of studs. Times this by the height to determine the stud meterage. Additional studs will be required at openings, determined by the dimension of the opening, and additional studs will be required at corners. Challenges you may come across would include inaccurate drawings. You may have contradicting information, and you may have contradicting materials and measurements. You may have limited measurements, so using scale drawings to establish the remainder. You may have a beam length along the length of the wall which is longer than the wall, or something that does not comply with the building code or the relevant New Zealand standards. You may have limited specifications, such as not specifying the exact materials or appliance required, for example, in a kitchen. The materials may not be available in New Zealand. Therefore, you have the issue of sourcing this material, allowing transport overseas and to site, and whether it is equivalent to a New Zealand product which complies with New Zealand legislation. Specified materials required which may be obsolete, so alternatives need to be found. You also look at the buildability of the structure. There will be assumptions and tags identified during your measurements. These have to be documented thoroughly, and also there's human error. Now for the tips. You ensure a simple step-by-step methodology, take a practical approach, understand the scope of works, follow the ANZ SMM 2022, write a shopping list of materials, mark off on the drawings what and where you have measured, pay attention to detail, ask questions from the design team, your superiors, colleagues, mentors, suppliers. This would be best in the early stages. Always double check the measurements and always get your work peer reviewed. The key points would be accuracy and attention to detail. As mentioned, accurate measurements are the foundation of successful project delivery. Measurements establish the project outcome, including but not limited to budget, resource allocation, timeline, and client satisfaction. Adherence to New Zealand legislation. Utilise standards, acts, and manufacturers' installation instructions. The main legislation devised for measurement is the Australian and New Zealand Standard Method of Measurement 2000 And 22, providing uniformity amongst the stakeholders. Non-adherence would lead to the building being unsafe, unhealthy, and not fit for purpose. As with the challenges and tips, review the drawings and specifications for accuracy and buildability, be methodical and practical, and list all the materials first prior to measuring them. Marking drawings to ensure you have measured everything. And with peer assistance and peer review, ask questions, document any assumptions and tags, collaborate with your peers, and always get your work peer reviewed. More detailed, concise, specialised videos are on our Patreon channel. Please subscribe using the link below.